So this is my attempt at the lab. During this lab, we're doing the same standards as others. We're going to demonstrate the video and computer model implementation of constant velocity and then comparing the results. What I've observed is my son Noah on his Razor scooter, and we are going to demonstrate Newton's second law, initially listed as F equals ma, but derived out as the final velocity, which we then discover that is related to Newton's first law, that an object will stay in motion once in motion because our net forces tend to be towards zero, or at least that's our assumption. The bigger assumption is that our computer model will match our video model results, assumed based on constant velocity, and we did find this to be true. The data that I used was my son on a scooter with a mass of 34 plus kilograms, and you can see the rest of the data. One difference you'll note here is my camera captured at 59.97 frames per second. So this time breakdown of 2.336 meters in 0.701 seconds gave us our initial velocity of 3.332 meters per second. So on to the video. You'll see here came along somewhat of a straight line. There was some curve. You might notice there's an angle tilt here, but we took along the same line based on the line of the Razor scooter itself, and a fairly straight line for a fairly constant velocity. So then in the code, using the code calling this a Razor scooter, I could put the mass in here, but it is irrelevant because it is zeroed out later, but just for kicks I will put one in now. And there we have it in kilograms. The position starting off at the 0, 0, 0 vector, and the initial velocity, what we found before, was the 3.332 going along the positive x-axis. I used a delta of 0.017 because that was the reported number from Tracker. However, that was a little bit different than what the actual number for Tracker was, and we'll explain that later. For the time duration, we looped through as instructed, and this is where we zero out the net forces, so therefore the constant velocity, and graphed it along. Back to the sheets. We had the data plotted here, the blue being the video and the red being the model. As you can see, they are fairly parallel with some differences. One thing that was a difference in the video results, it gave me a different time. Instead of 0.017, it was 0.01668. But I did the 0.017 based on the Tracker numbers, but still fairly satisfied with the results. And then in conclusion, we did find it to be true. What if the results changed simply the x-axis? If flipped, we would have a negative velocity. We would have a negative distance accomplished. But also, what does it mean? Can you do how many pushes and pulls for net zero? It's not possible to list all of them, but it is definitely possible to begin listing them. For example, the force of gravity, etc., etc. It would be, for me, it would be interesting to find out what are the forces that I'm not accounting for. All in all, it was a fun experiment. I look forward to doing more videos.